So now we're going to move on to proving or showing derivatives of trig functions. So we're no longer using just the limit laws, but now we're using the derivative laws that we got from Unit 2. So let's start by finding the derivative of sine of x. So we don't have any tricks for or rules for that one, so we'll have to use the derivative definition, which says, I'm just going to write it both ways, so just to be clear, this is the derivative of sine of x. Let's see, the definition tells us that we take the function at x plus h minus the function at x, all divided by h. So that limit, we're going to plug in our f of x plus h. So let's do some pre-work here. So what are we going to plug into this definition? Let's see. F of x is just sine of x. So this negative sine of f of x will just be negative sine of x. For the first one, the f of x plus h, what does that look like? We need a little more space for that one. So f of x plus h, that equals sine of x plus h. Now we can't separate the x plus h because it's being taken as the full input of sine. So in order to separate the x and the h, what I have to do is apply the addition identity. So I'm going to go back up to my identities page, and I have this identity right here that will allow me to separate the x and the h, just like this one separates x and y. So that's sine of x plus y equals sine of x times cosine of x plus cosine of x and sine of y. So let's apply that over to our x plus h. So that becomes sine of x times cosine of h plus, so I'm going to put parentheses around the h and the x, plus cosine of x times sine of h. So that is going to go into the first part of that numerator for the derivative. So now let's substitute in. So I have this is equal to the limit as h goes to 0 of this orange part, the function of x plus h input is sine of x times cosine of h plus cosine of x times sine of h, and then minus f of x is minus sine of x all over h. So there's my definition of derivative. To simplify this, we're going to start by switching the sine of x term, just switching those two terms so that I'll get my sine of x grouped with my other sine of x so I can factor those out. So my first step is to just change the order. So the terms with sine of x are together which will make it easier to factor those out and single them out. So that gives me so it's not going to change much. The first term changes, stays the same. I'm just going to change the order. So switching the sine of x with the cosine x sine of h. And everything else stays the same. The reason I wanted to do that is because now I'm going to take the sine of x out of these first two terms. So I'm going to factor out sine of x from those first two terms. Can't do it from all three because there is no sine of x in the third term. So taking that sine of x out looks like this. And then I'm left with cosine of h minus 1. And I still have the plus cosine x times sine of h. And all of this is over h. But in the same step, instead of writing it all over h, I'm actually going to decompose this fraction and put this part over h and this part over h and make it two separate fractions. So I factored out the sine of x, and I'm also going to decompose it. And you can see now when I took out why I took out that sine of x, or maybe you can see it, because that way I have over here, I have this, which looks like our second identity. And I also have this, which looks like our first identity. So that decomposing of those fractions helps me get those identities out and split things up into stuff I already know. So now I can split this up a little more, and I'm going to write limit as h goes to 0 of sine of x times cosine of h minus 1 all over h. Splitting up that multiplication a bit. And same with the second one. I'm going to split up this multiplication a bit. Just rewriting it. It's really the same thing. I just want to make it look more obvious. So now I'm going to take the limit of the products. Remember, I can split up limits by product and by addition. So I'm not manipulating derivatives here. Even though I'm making a derivative, I'm actually manipulating the limit. So I'm using the definition of derivative, but by writing the limit. So the limit as h goes to 0 of sine of x, this piece, sine of x, the limit of that is just sine of x, right? There's no h in there, so I can't substitute an h. So the limit of a constant is, or sine of x is just sine of x. The limit of the second piece, this thing, is 0. The limit of this piece is 1. And the limit of cosine x, remember that's not an h, it's an x. So that's just cosine x. So that gives me 0 plus cosine x, which gives me just cosine x. So that's a pretty big conclusion. Let's write it big. So in conclusion, the derivative of sine of x equals cosine of x, which is kind of fascinating. You think about it, that one curve has a derivative that's the other one. Let's investigate that a little bit, actually. So let's go look at those graphs. So here's my graph of sine. And if I think about the derivative of a graph of one function, I start by looking for the zeros, right? So every time I see a horizontal tangent line, that should correspond with a root on the derivative. So this is sine, and this will be the derivative of sine. So horizontal tangent line means it's a root. Horizontal tangent line, so there's all my roots. And then from here to here, I'm increasing, so that's positive. So it's above the x-axis. And then I'm decreasing, so it goes below the x-axis. And then from here to here, I'm increasing, that goes above. So you can see how the graph of sine of x and its derivative correspond. And once you've graphed that, you can see, hey, this is actually the cosine function. It's starting here, and it actually is our cosine function. So if you look back at our reminder page, we have our two functions and how sine and cosine correspond. So you can see by these two graphs how the derivative of sine is actually cosine. And the question is, so that's our graph of our derivative of sine. So we're going to memorize that one. Now that kind of turns our question to, okay, so is the derivative of cosine sine? Does it go backwards like that? Well, let's see. Let's investigate. So let's draw another curve, like the one above. We can actually just think about this function not as the derivative of sine, but as cosine itself. Okay, this is the cosine curve. So looking at cosine and finding the derivative of cosine. Okay, so whenever cosine has a horizontal tangent line, that should correspond with a 0 on its derivative function. So let's line these up. So every time I have a 0 tangent line, I should have a 0 on this graph. Or a root, I'm sorry. So a flat horizontal tangent line tells me that I have a root on the derivative. And it looks like from this root to this root, this graph is decreasing. It's going down, which means before that root, it's below the x-axis. Here we're increasing, so this part should be above the x-axis, and then we decrease, decreasing here, so that should be below, and then increasing, so that should be above. Now my 0 line, my x equals 0 line is right here. So does that look like the sine function? It looks awfully close, but a little bit different, right? Our sine function starts at 0 and goes up. And this is the flip of that. So the derivative of cosine is actually negative sine. So the derivative of the sine function equals cosine, but the derivative of the cosine function equals negative sine. So a little bit different. So this similar analysis and also a proof similar to what we did on the previous page, which was also included in your book, will show that, I have a bit of a mess here. I'm going to erase this line. Show that the derivative of cosine of x is actually negative sine of x.